Hello, and welcome to our osmosis lab report by Stacy and Ashley. So let's start off by establishing what's osmosis. Osmosis is the movement of water from an area of low solute concentration to an area of high solute concentration. This tends to happen in our cell membranes. When a solute can't get through, what happens is osmosis will take over and the diffusion of water will come into our cells to make an equal ratio of solute in the extracellular environment to solute in the intracellular environment. Now, a cell with an environment with a low solute concentration will be called hypotonic in comparison to the cell. A cellular environment that has the same amount or an equal amount of solute to the intracellular environment is going to be called isotonic. And lastly, we have hypertonic, which is what the extracellular environment is called when it has more solutes than the cell itself. So our question, the one that we're looking to answer, is how does the concentration gradient affect the rate of water movement across a membrane? How does the amount of solutes affect the rate of osmosis? That's essentially all they're asking. So that leads us to the question, how do we find the answer? And so what we want to do is we want to make artificial cells, and we want to put them into an into an environment that will show us diffusion. Now, how do we do this? We're going to create artificial cells using dialysis tubing. And there's going to be 4 different cells, and cell 1 is going to be our control. It's going to have a 0% sucrose solution. Cell number 2 is going to have a 12% sucrose solution. Cell number 3 is going to have a 21% sucrose solution, and cell number 4 is going to have a 30% sucrose solution. Now, each cell, what will happen is we'll grab the dialysis tubing, which will be moist at this point, and we'll close up the end, because if not, our sucrose solution will leak out. We're going to close off the end with clips, make sure that they snap so that you know that your sucrose solution isn't going into your extracellular environment. Using a funnel and your already measured sucrose solution, take 10 milliliters. Using a funnel, open your dialysis tubing, place it underneath, and pour it in. Usually it helps a lot more if you have a partner to help you out, because then you're not all over the place. Again, roll it. Try to leave as little air as possible. That way you can really see a difference. You'll understand in a few moments. Lastly, you'll want to weigh each one of the cells and record them. Be sure to have some place to put them consistently so that you know that the order that you took them out is the order that you'll put them back in. Place the cells into their extracellular environment. So now, what we did is we had a beaker with 500 milliliters of water. That was our extracellular environment in comparison to our cells with the sucrose solution. Now, to find the rate of osmosis, be sure to take out and weigh each cell every 10 minutes for an hour. That's a total of 6 times that you're going to have to take them out and weigh them. And your weight in the future will show you the difference in osmosis. Record your results. It's very important. It's crucial. So our results, me and Ashley's results for this experiment, we jotted this down in a table, and now we have this beautiful masterpiece. Our time spans from 0 to 60 minutes, and on the bottom we have the total difference of osmosis. So let's begin by establishing cell number 1 is our 0% solution, cell number 2 is our 12% solution, cell number 3 is our 21% solution, cell number 4 is our 30% solution. Cell number 1 was our control, as you may recall, and we started off with 22.47 grams in total weight, and we ended with 22.57 grams of total weight for a total difference of 0.1 gram. This means 1 gram of 0.1 gram of water diffused into the cell to try to reach equilibrium. which in a perfect world shouldn't have happened, because what was in the cell was water and what was outside of the cell was water. But again, this isn't a perfect world, so our results may be a little flawed. Our second cell, our 12% solution, we started off with 22.6 grams of total weight, and we ended up with 24.61 grams of total weight, and this gave us 2.1 grams of total water coming into the cell. Now, this tells us that between cell 1 and cell 2, the rate of diffusion increased because there is a higher amount of, where'd my mouse go? I'm sorry. Which gives us a higher amount of sucrose solution. Now, cell number 3, as we can recall, that was our 21% solution. Excuse me. And we began with 23.38 grams of total weight, and we finished with 26.68 grams of total weight. That's a total difference of 3.3 grams that diffused into our cell. Again, there's been an increase from our 0% to our 21%. There's been an increase from our 12% to our 3.3%. The rate of osmosis is increasing as the amount of solutes increase. Finally, our fourth cell, we started off with 24.02 grams of total weight, and we finished with 27.48 grams of total weight, for a total difference of 3.46 grams of water diffused into the cell. As I've established before, as the amount of solute increases, or the solute concentration, the rate of osmosis increases. So our first cell was isotonic, and the rate of osmosis was very low. There was nearly none. It was nearly non-existent. Our second cell was slightly hypotonic, and the rate of osmosis was low. There was something going on, but not as much as the other two. Our third cell was hypotonic, and the rate of osmosis was somewhat high. And our fourth cell was very hypotonic, and the rate of osmosis was high. Now, these four, there was a definite change in their shape. Our first cell didn't really have a shape. You could move it, you can squish it. It was very watery. Now, our second cell was slightly hypotonic, and with the rate of osmosis, there was a little bit more rigidity. It was a bit tougher, but not in monumental amounts. Our third cell definitely had a change. It was a lot stronger. If you poked it, it definitely had a resistance. But our fourth cell, the one with the 30% sucrose concentration, was rigid. It was swollen. It had definitely had a large increase in water. Now, shrinking, exploding, and normalcy. Quite the title, I realize. But it will make more sense once we watch this video. This video is about how osmosis affects our cells, animal cells, because if this were plant cells, it'd be a completely different story. But anyway, this video will show us the effects of a hypertonic, isotonic, and hypotonic environment. And we should watch. I apologize in advance for all the shaking. You'll understand in a minute. So, presenting osmosis in a cell. And a cell in an isotonic environment. Now, at this point, we had our cell, our sheep's blood, which is what we're looking at, was in a 0.9% sodium concentration. That is the ideal. That is the ideal concentration to be in for our cells. So, unfortunately, I don't have a very steady hand, but we can see that they're round, that they have a very good shape and structure to them. This is what our cells typically look like on a normal day, because they are in an isotonic environment. Cells in the hypertonic environment were actually at a 0% salinity, meaning our cells had, I was reading hypotonic. Cells in the hypertonic environment had a 10% salinity. This is 9.1% higher than the normal salinity for our environment. Now, as we can see, our cells have shrunk. It's what we call crenated. Those cells that we just saw were crenated. They had shrunk in the hypertonic solution. A cell in a hypotonic solution, which is at a 0% salinity, we can see that we're looking at fragments of nothing. And that is because water rushed into the cells and forced them to explode. Remember that a hypotonic solution will rush into I'm sorry, I had a cough. Remember that in a hypotonic solution environment, the water will go into the cells to try to reach a type of equilibrium. If too much water goes into our cells, they'll eventually explode. So, our conclusions. What have we learned? What did we find out? The blood is an example of how cells react to osmosis. A cell in a hypertonic environment is crenated. It'll shrink. This is because the water will flow out of the cell. A cell hypotonic to its environment will swell and eventually explode. A cell isotonic to its environment will remain at a stable size. Isotonicity is the way to go. It's what cool cells do. Conclusion continued. So, applying the knowledge that we've gained from the experiment and the analysis, we know that the concentration gradient will have an impact on the tonicity of a solution. And by having an impact on the tonicity solution, the rate of osmosis will increase depending the rate of osmosis will increase into the cell if it is a hypotonic solution. If it's a hypertonic, the rate of osmosis will increase going out of the cell. And that's the end of our show. Thank you so much for watching. Bye!